This is a walking talking mock for Chemistry 1. It's the higher tier, and if you're in my year 11s, this is the one that you've just sat for your mock exam. I'm going to go through it, pointing out the mistakes that people have made, and also questions that were done really well, and of course the correct answers. Question 1. There are 8 elements in the second row, lithium to neon, of the periodic table. Figure 1 shows an atom with 2 energy levels, or shells. Complete Figure 1 to show the electronic structure of a boron atom. Right, now the first mistake, the first question on the paper, lots of people missed question 1A1 and went straight on to question 1A2. So they lost a mark there from not reading the paper properly. Now what you've got to do for this one is go and find boron on your periodic table, and you should see that it has got 5 protons and therefore it's got 5 electrons. And following the rules, you should have drawn 2 on the inner shell and then 3 on the outer shell. Question 1A2. What does the central part labelled Z represent in Figure 1? It's the nucleus. Question 1A3. Name the subatomic particles in part Z of the boron atom. Give the relative charges of these subatomic particles. So for this one, you should have put protons and neutrons. So that was worth 1 mark here. The next mark was for saying what the charges are. So on the proton it's +1, and on the neutron it's 0. Lots of people put electrons here. If you notice, it's just saying part Z, so it's just wanting to know about the nucleus. So if you put electrons down, that is not allowed. Question 1B. The electronic structure of a neon atom is shown in Figure 2. It's not correct. Explain what is wrong with the electronic structure shown in Figure 2. So, the first thing, which is probably pretty obvious to most people, and most people did get it right, that it's got more than 2 electrons on the inner shell. And remembering that it can only hold 2 in the first shell. The second point is to say that there are too few electrons in the second shell. Okay, now neon should have 8 electrons in its outer shell because it's got a stable arrangement, and it's in a group 8 of the periodic table, or group 0. The majority of people managed to get these 2 points right. The next point is not so obvious, and it requires you just having a quick look at your periodic table to see how many electrons neon should have. And neon should have 10. So if you count how many is here, you've got 2, 4, 6, 8, 9. So the third mark comes from saying that neon doesn't have 9 electrons, it has 10 electrons. Question 2 is a question about hydrocarbons. Most of the hydrocarbons in crude oil are alkanes. Large alkane molecules can be cracked to produce more useful molecules. The equation shows the cracking of dodecane. Give 2 conditions used to crack large alkane molecules. Okay, so this is a high temperature and a catalyst. So most people got the high temperature bit, but not everybody remembered that a catalyst is needed for this reaction. Question 2A2. The products hexene and ethene are alkenes. Complete the sentence. When alkenes react with bromine water, the colour changes from orange to colourless. Lots of people lost marks here because they put clear. Now, you can't have that it becomes clear. You must put that it is colourless. Question 2A3. Butane is an alkane. Complete the displayed formula of butane. So here we've got 2 carbons and we've got 5 hydrogens. If we look at the formula, we need another 2 carbons, and then in an alkane they're all saturated bonds, so then we go in and fill in our hydrogens. Quick check that we've got 4 carbons, and then we've got 2, 4, 6, 8, 9, 10 hydrogens, which makes it correct. I think most people did a really good job on this question, and most people managed to get it right. Question 2b. A group of students investigated the energy released by the combustion of 4 hydrocarbon fuels. Figure 3 shows the apparatus used. So you've got a beaker, thermometer, 100 centimetre cube of water, a spirit burner, and a hydrocarbon fuel. Each hydrocarbon fuel was burned for 2 minutes. Table 1 shows the student's results. So here we've got the hydrocarbons that she used, the mass of the fuel used, the temperature increase of the water, the energy released by the fuel, and the energy released per gram of fuel. Right, so if we look at decane, we can see that it's got its energy released per 1 gram of fuel missing. Question 2b1. Calculate the energy released by 1 gram of decane in kilojoules. So this comes from noticing in the table that the amount released per gram is 24.36 kilojoules. And if you divide that by how many grams were burnt, so 1.2, you get an answer of 20.3. So the energy released is 20.3 kilojoules. I think most people did really well on that question and managed to get the correct answer. Question 2b2. Suggest one improvement to the apparatus or the use of apparatus that would make the temperature increase of the water for each fuel more accurate. Okay, now for this one, they're looking for one suggestion and why it's an improvement. Now, the one from the mark scheme says to use a lid in order to reduce energy and heat loss. However, you could have got marks for saying things like insulate the beaker to prevent heat loss, or use a metal can as it's a better conductor. You could also have allow stir to distribute the energy around. Now, one thing here that lots of people said was they use a thermometer or a digital thermometer because it makes it more accurate. Now, it's wanting the temperature increase of the water more accurate, not the reading of it. So to make this more accurate, what you need to do is make sure that most of the energy that possibly can is going into heating the water and not being lost to the surroundings. So that's where quite a few people tripped up on that one by putting use a digital thermometer. Question 2b3. The student noticed that the bottom of the beaker became covered in black substance when burning these fuels. Name the black substance, suggest why it's produced. Now, the substance is carbon, but you can have a mark for putting soot. And most people managed to get that, but could not say where it's come from or why it's produced. It's come from the incomplete combustion of the fuel, which happens when there's a limited supply of oxygen. Question 2b4. A student concluded that hexane is the best of the 4 fuels. Give 2 reasons why the results in Table 1 support this conclusion. This question was done really well by most people. They noticed that hexane gives out the greatest energy per gram and that it produces the least amount of smoke. The reason why people might have lost marks on this question is that they just put the greatest energy when they needed to put greatest energy per gram. So remember, in your questions, you need to be specific. Question 2c. In this question, you will be assessed on using good English, organising information clearly, and using specialist terms where appropriate. Most car engines use petrol as a fuel. Petrol is produced from the fractional distillation of crude oil. Crude oil is a mixture of hydrocarbons. Sulfur is an impurity in crude oil. Car engines could be developed to burn hydrogen as a fuel. Hydrogen is produced from natural gas. Natural gas is mainly methane. Table 2 shows information about petrol and hydrogen. So we've got the state of the fuel at room temperature. For petrol is liquid and hydrogen is gas. We've got the word equation for the combustion of the fuel. Petrol plus oxygen gives carbon dioxide and water. And hydrogen plus oxygen gives water. And then the energy released from the combustion of 1 gram of the fuel. You've got 47 kilojoules for petrol and 142 kilojoules for hydrogen. Describe the advantages and disadvantages of using hydrogen instead of petrol. Use the information given and your knowledge and understanding to answer the question. I was really pleased when I came to mark this question because I'd seen a lot of people that were using the fishbone organiser to try and plan this out, and as a result there were quite a high proportion of 5 and 6 marks given for this question. So well done those people for taking the advice. You could have picked up most of the marks for this question just from summarising what you've been given in that table. So we'll do the advantages of using hydrogen first. I'll just do the bullet points so it's easy for you to see where the marks are coming from. So one advantage of using hydrogen is that it only produces water. Could have also picked up another mark from saying that combustion of hydrogen does not produce carbon dioxide, so it does not contribute to global warming or climate change. And you could also have said that combustion of hydrogen does not produce sulfur dioxide, so it does not contribute to acid rain. For this section of the advantages of hydrogen, you could have also talked about the disadvantages of using petrol. And incomplete combustion of petrol produces carbon monoxide, which is toxic. It also produces particulates that contribute to global dimming. You could also have said that petrol comes from a non-renewable resource, but there are renewable or other methods of producing hydrogen. You could also say that hydrogen releases more energy, so it's more efficient. And on now to the disadvantages of using hydrogen. Hydrogen is a gas, so it's difficult to store or transfer. Hydrogen gas is flammable, so there could be leaks which cause risks of explosions. You could also say that the majority of hydrogen is produced from fossil fuels which are running out, and that the hydrogen cannot be used in existing car engines, so there would have to be modification of engines or development or replacements that are needed. And then the last point that you could have included in this answer is that there's a lack of filling stations, which makes it very difficult to refuel your vehicle. Question 3. Metals are extracted from ores in the Earth's crust. Some ores contain metal carbonates and some ores contain metal oxides. Name the type of reaction that happens when a metal carbonate is heated. Now, the answer for this is thermal decomposition. A few people put in electrolysis for this answer, but your clue really is when it says heated. Question 3A2. Which solid product is formed when copper carbonate is heated? Okay, so for this one, what we're left with is copper oxide. Question 3B. A student investigated heating 4 metal carbonates. Figure 4 shows the apparatus used. 10 kilograms of metal carbonate heated in a boiling tube, and then we've got a bung and a delivery tube, and then into some lime water. The student heated each metal carbonate for 5 minutes. Table 3 shows the results. So they've done copper carbonate, magnesium carbonate, potassium carbonate and zinc carbonate. They all start with 10 grams at the start, and then it gives you the mass after heating. And then we have got whether or not it turns lime water cloudy, which indicates the presence of CO2. Question 3B1 asks us to explain the results for potassium carbonate. Now for this question, you've got to say that the potassium carbonate did not decompose when heated. You could also have said that the temperature was not high enough because potassium is a more reactive metal, so it would require more energy to decompose the potassium carbonate. You need to also have said that the mass did not change and the lime water did not go cloudy. And then you also need to say that the lime water did not go cloudy because no CO2 was produced because it did not decompose. And you needed to make all 3 of these points to get the marks. Lots of people dropped a mark here because they didn't actually mention CO2 by name. Question 3B2. Suggest how the reactivity series can be used to predict which metal carbonate reacts most easily when heated. So for this one, you need to say that the less reactive the metal, the more its carbonate will decompose, or the more easily its carbonate will decompose. I'd have also got the marks here from saying the more reactive the metal, the more difficult its carbonate will decompose when heated. Question 3c, figure 5 shows a simple life cycle of a car body. Quarry iron ore, extract iron from blast furnace, convert iron into steel, make car body, use the car, recycle the steel. Complete the sentence. Iron ores must contain enough iron to make it economical to extract or to make it worthwhile extracting. Question 3c2. Some iron ores contain iron oxide. Complete and balance the equation for a reaction to produce iron from iron oxide. So it's telling us that we're producing iron. Iron symbol is Fe. Lots of people made a mistake here because they put Fe2, which then had a knock-on effect for the balancing of their equation. Now the correct balance is 2, 3, 4 and 3. However, don't panic too much, because if you did put Fe2 and you balanced it successfully, then you get 1 mark for the balancing of the equation. Question 3c3. Give 2 reasons why iron produced in a blast furnace is converted into steel. Okay, so for this one, you need to say that the iron produced is very brittle. Then for the second mark, you need to say that the steel is an alloy and it is much stronger. Lots of people lost marks here because however they said steel is strong, they didn't say that it was because the iron itself was brittle. Question 3c4. When a car reaches the end of its useful life, the car body can be recycled, reused, or sent to landfill. Give 3 reasons why a steel car body should be recycled and not reused or sent to landfill. Okay, so first mark here is for saying what's good about recycling. And recycling conserves the iron, or conserves the energy, or minimises pollution, or reduces the need to quarry. So any of those points would have got you 1 of the marks for talking about recycling. The next mark comes from saying why it might not be appropriate sometimes to reuse metal. Now this could be because it might be damaged, the paint might have been removed, there might be rust, the metal also might be fatigued or weaker. And then the last mark is for talking about why not to use landfill, and it's because landfill sites have got limited space, or it can cause the loss of habitats to some organisms. And you could have also said to reduce the use of landfill. Question 4. Ethanol can be made from plants and from crude oil, as shown. So it gives us the methods of production for both plants and crude oil. Question 4a1. Describe how the solution of sugar in water is used to produce a mixture of ethanol and water. Now, this question was not done very well because there's such specific things that they are wanting you to write. Okay, and the 2 marks here are for saying, number 1, add yeast, and number 2, then the fermentation process produces ethanol and water. So if you didn't know those things, then you've got a very, very low chance of getting the marks. So if this is something that you missed or you got wrong, then I suggest that you go back and you look at ethanol production. And then on to question 4a2. Describe how ethanol is produced from ethene. Again, it's looking for 2 very specific things here. So if you don't know them, you've got a low chance of getting it right. And what you should have put is by hydration with steam. That will get you 1 mark. And the second mark is for saying in the presence of a catalyst. And the correctly named catalyst for this reaction would be phosphoric acid, although it's not required for you to get the mark. Question 4b. Explain 1 advantage and 1 disadvantage of using crude oil to make ethanol instead of using plants. Now here, what you need to have said is crude oil produces pure ethanol, or is a reliable source of ethanol, and is not affected by growth or weather conditions, or it does not cause food shortages because there's no farmland used. And then some of the disadvantages include saying that crude oil is non-renewable or it's a finite resource. You could also put that it will eventually run out, whereas plants will grow again. And then you could also say that the use of crude oil releases more carbon dioxide and then adds to global warming. Question 4c. Ethanol has a boiling point of 78 degrees. Water has a boiling point of 100 degrees. Describe how distillation is used to separate a mixture of ethanol and water. So the first mark here is for saying heat the mixture. And then you have to talk about how they have different boiling points. So the ethanol has got a lower boiling point than water, so it will vaporise first. Then for the last mark, you've got to say that you need to condense the vapour back into a liquid. Also being a bit more specific and said that the two substances condense at different temperatures. Question 5. This question is about vegetable oils. 5a. Explain why using vegetable oils as biofuels does not increase global warming. Okay, so for this one, they want you to talk about how this is carbon neutral. Alright, so lots of people messed up on this one because they put that burning vegetable oils as biofuels does not release carbon dioxide. It does release carbon dioxide, however, during its lifetime, when it's growing and photosynthesizing, it takes in carbon dioxide. So when it's burnt, it means that there's no net increase in the carbon dioxide in the atmosphere. So basically, it takes in as much as it gives out. So it does give out carbon dioxide, but it doesn't add, so there's no net increase. If you didn't manage to get any of those marks at all, it says in the mark scheme that you could be allowed 1 mark for stating that carbon dioxide causes global warming. So remember, if you don't know the answer, write something down because you could get a mark. Question 5b. Describe how and explain why vegetable oils are hardened for use in foods. So describe how firstly. They react with hydrogen in a process called hydrogenation. The conditions for this reaction is in the presence of a nickel catalyst at 60 degrees C. And they are the first 3 marks for this question. So 1 for saying hydrogenation, 1 for saying nickel catalyst, and 1 for saying 60 degrees C. Then you need to say that vegetable oils are unsaturated, or that they have carbon-carbon double bonds. So the fact that they do have the double bond is why we can add more hydrogen to them. Okay, so it makes them saturated. And then the reason that we do this is to make them solid at room temperature, which makes them useful as things like spreads or margarine. And even if you give them a higher melting point, that will get you a mark too. And that brings us to the end of the question paper. Well done for completing this exam. I know some of it might have been a little bit difficult, but this is going to be you at your worst point. You have still got time to revise and make things better. So hopefully after you've watched this video, you can see where you went wrong and where you lost marks, and then next time hopefully you won't make the same mistakes again. Well done everyone.